So I was asked for help on graphing the tangent curve, so we're just going to do that. So firstly, we're going to graph y equals tangent of x. So firstly, we should know the generic table for the tangent curve, and the important points for that are negative 90, negative 45, 0, 45, and 90 degrees, and that should cover all the 5 key points for the tangent curve. Now you'll notice that runs between negative 90 and 90 degrees, and that's because the period of this graph is going to be pi, meaning it completes the full cycle between negative 90 and 90, or a full 180 degrees. So important to know is whatever your period is, your scale on your x-axis has to be half of that. So the scale should be pi divided by 2. So that means we're going to place enough space here, and we're going to count by pi's over 2. So I'm going to do it every 4 lines. So that's pi over 2, and this is going to be negative pi over 2. So that's 90 degrees and negative 90 degrees, and those are where the asymptotes go, because those are the undefined values on the tangent curve. Oh, I miscounted. This is only 3 over. I should really go 4 over. So next, 0 is 0 for the tangent curve, so that's our middle point here. And then 45 and negative 45 are 1, so we're going to go to 1 and negative 1. And the graph will start at negative infinity, go through negative 1, pass through 0, and then go through 1. And this graph will repeat on the other side as well. So if I go another 4 units, that's where 0 goes. Another 4 units here, that's where the asymptote goes. I can plot the 1 and the negative 1, and I can make the second instance of this curve, each one approaching their own asymptotes. So this graph has x-intercepts at 0. This would be pi, because this would be another 90 degrees, or 2 pi over 2, which is just pi. The next asymptote would be at 3 pi over 2, and so on. We can do this on both sides, moving 90 degrees at a time to plot a 0, and then another 90 degrees to plot an asymptote, and so on. I'll show you another example with different values. So let's do, I'm just going to make this up. So y equals negative 2 tangent of, let's say, 4x. All right, so in this case, we do need to know the general look of the standard tangent curve, but we're going to also apply a couple other things. So firstly, we need to know that there's a negative here, so that means we're going to be flipping our graph over the x-axis. So all the points that were negative will become positive, all the points that were positive will become negative. Also, the values that were 1s before will suddenly become 2s. So for instance, normally at negative 45, which is halfway between the end of the curve and the center of the curve, and at 45, which is halfway between the asymptote and the intercept, normally those would be 1s, but because we have a value of negative 2, those will become the opposite sign. So normally this would be negative 1, but because of the negative 2, it's going to be positive 2. And because this was normally negative 1, this is going to become negative 2. So those are now the important values we need to know. The negative 90 and the 90 are still undefined. Now, these numbers are technically no longer correct because we're not using the same period. So we have to find the period. So the period is equal to pi, not 2 pi, because the tangent graph only takes 180 degrees to graph, so it's pi divided by the b value, so 4 in this case. But for the scale, we're going to want to scale this by half of that, so pi over 8. So I'm going to do this 4 lines over again. So I'm going to go, still graphing these 4 over, but now this is going to be labeled pi over 8, and this will be pi over 8 as well. That means the distance between those two is pi over 4, which is the period. Next, we're going to plot all the points. So instead of at negative 90, it's going to be at this pi over 8, negative pi over 8 in this case. This is going to be at positive pi over 8. In between at the 45 degrees are going to be negative pi over 16 and pi over 16. This is still 0. So we're going to plot the positive 2 here, the 0 here, and the negative 2 here. And the graph's going to look something like this. and then we'll travel another 4 points over to get our next 0, and another 4 points over to get our next asymptote, and the graph will repeat this process on both sides. All right, let's do one with a horizontal shift. So I think I did problems, meant to do problem, we'll do problem 8 now. Okay, so firstly, the negative tells us we're going to be flipping the graph, and the 2 tells us that the 1s are going to go to 2 and negative 2, and the negative pi over 2 tells us to move the graph over negative pi over 2 units to the right. Because remember, a negative actually means right. There's no midline here, so we're not going to move it up or down, but this 2 would tell us to move it up or down. So we're going to sketch this graph here. We need to know the period, so this 2 here tells us that the period is going to be pi over b, so it's pi over 2. And then we're going to sketch, our scale is going to be half of that, so pi over 4. So we're going to be counting by pi over 4. So I'm going to go 4 units over, call this pi over 4. Call negative pi over 4. Call this one pi over 4. Now I need to shift the graph pi over 2 units to the right. So pi over 2 is 2 quarters, so that's actually means I'm going to move from the middle 4 and 4. So this is going to be pi over 2, or what normally pi over 2 would be. So this is where our 0 is going to go. Then our value is negative 2, so we're actually going to start at positive 2 and then go to negative 2, because normally we would start at negative 1 and go to 1, but because we have the negative 2a value, this is going to change. So this is our asymptote now. We're going to put another one 4 spaces over, and this is going to be our graph. Hopefully this was helpful.